You know, when you think about what keeps astronomers up at night, you probably think of, I don't know, black holes or maybe a giant asteroid, big, messy, chaotic things.
The destructive side of the universe, yeah.
Exactly. But right now, the thing that's really causing a stir is the complete opposite. Mm-hmm. It's the unsettling idea that something out there is moving with a level of precision where there just shouldn't be any.
Right. It's that moment when the math stops looking messy, like nature, and starts looking, well, deliberate, like engineering.
And that is the absolute core of the mystery around 3I Atlas. This is an interstellar object, something from outside our solar system, that we started tracking back in 2024. Mm-hmm. At first, it just got logged like any other visitor. You know, chunk of ice and rock and swing around the sun and head back out. Business as usual.
But then the new orbital calculations came in.
And they showed something completely different. 3I Atlas isn't just passing through. It's executing what looks like a precision approach directly towards Jupiter.
And that's what we need to get into today. The thing that's splitting the scientific community isn't that it's going near Jupiter. That happens all the time. Jupiter's huge.
Right.
It's the surgical accuracy of its trajectory. So for this deep dive, we're going to look at the data and try to understand the two sides here. Is this just an unbelievably lucky cosmic accident?
Yeah.
Or are we watching the opening moves of something deliberately placed?
Maybe even the deployment phase of a mission that's been in motion for longer than, well, human civilization.
The data is real. The interpretation is where it gets complicated.
Okay, so let's start with that precision problem, because that's really where everything starts to feel off.
Well, the initial tracking, like you said, just confirmed it was interstellar, came from outside, so we assumed it was basically a cosmic tumbleweed, just drifting.
But it wasn't drifting, was it? When they ran the long-term numbers, it was headed for a very, very specific gravitational sweet spot.
A spot that allows for long-term stability. And that spot is defined by something called Jupiter's Hill radius.
So the Hill radius, what is that exactly?
Think of it as Jupiter's personal gravity bubble. It's this three-dimensional space around the planet where its gravity is stronger than the sun's.
Ah, okay.
So if you want to park a satellite in orbit around Jupiter, you have to get it inside that bubble. It's like a gravitational harbor. And it's huge. It extends about 53 million kilometers from Jupiter's center.
53 million kilometers. That's an enormous target. So you'd think things might skim by it randomly.
They do. But 3I Atlas isn't just skimming. The calculated intercept point is 53.445 million kilometers.
Okay.
And here's the part that you really have to pause on. The margin of error on that number is just 0.06 million kilometers.
All right, so 60,000 kilometers over a journey of billions of kilometers.
Exactly. It's less than 0.1% deviation. That's not a comet. That's what we'd call spacecraft level targeting.
That just doesn't sound possible.
The sources use a great analogy. They say, imagine throwing a dart from New York City and hitting a moving bullseye in Los Angeles. Oh, and you threw the dart 7 years ago.
Wow. Yeah, that puts it in perspective. For a natural comet, which is basically a lumpy, dirty snowball getting pushed around by random forces, that's not just luck. That's impossible luck.
It is. A normal flyby is chaotic. This is hitting a specific gravitational boundary with pinpoint accuracy. It requires either impossible luck or active guidance. It looks just like an insertion maneuver.
And that idea of active guidance, that's where the timing comes in. Because there was a course correction. Let's talk about what happened after it passed perihelion, its closest point to the sun back in early 2025.
Right. Normally, that's when a comet gets messy. The sun's heat makes ice and gas shoot out in violent jets.
Like little thrusters, but completely random.
Exactly. They're chaotic. So you'd expect the comet's predicted path to get fuzzier, less certain.
But with 3I Atlas, the opposite happened.
The opposite. The trajectory toward Jupiter's Hill radius became more refined, more exact. It was as if someone had just made a perfect, subtle course correction. The path tightened, which is a classic signature of controlled thrust.
And it flew pretty close to Earth on its way, didn't it?
It did. And it completely ignored us. No maneuvers, no weird heat signatures, no sensors turning on, nothing. It's like we weren't the destination, we were just scenery.
Just scenery. That's unsettling. So the destination is Jupiter, but the smoking gun, the proof of intent, might be in the timing of that maneuver. It happened during something called solar conjunction.
Yes. Solar conjunction is when the object, from our point of view on Earth, passes directly behind the sun.
So we can't see it.
For about 40 to 60 hours, it's a complete telemetry blackout. The sun's glare just blinds us.
And during that exact blind spot, That's when the non-gravitational acceleration event happened, the course correction.
Precisely.
But how do we even know it happened if we couldn't see it?
That's a great question. We calculate its path based purely on gravity. We call that the gravitational trajectory. Then, when it emerges from behind the sun, we measure where it actually is.
And the difference is the push it got.
The difference is the non-gravitational acceleration. And in this case, it was a short, clean burst of speed and a change in direction, exactly what was needed to lock in that final approach.
So it happened when we weren't looking. I mean, the implication is pretty obvious. Either that's an incredible coincidence,
or someone knew exactly when to make their move without being watched. Now, to be fair, the physics of perihelion maximum heating lines up with conjunction, so there's a natural reason for some activity.
but not for it to be so perfectly targeted.
Exactly, and that's the split in the community.
Let's unpack that. So Camp 1 is the conventional view.
Camp 1 says it's just a dirty snowball. The push was from outgassing. An ice jet just happened to fire in the right direction at the right time. Case closed.
But the data makes that hard to swallow, right? There are two big problems with that theory.
Two big problems. First, the visual data, the symmetry. When a comet outgasses, the jets are messy and asymmetrical. You get these patchy, rotating comas. 3i Atlas, on the other hand, has an unusually symmetrical coma. It looks stable, almost artificially so. It's not tumbling and spraying gas everywhere.
So it looks like a clean directional push.
Which brings us to the second and much bigger problem, the vector, the direction of that push. We know exactly what direction the push needed to be in to make that orbital correction.
Yeah.
And the acceleration vector we measured points in that precise direction. For a natural jet to do that, the one specific ice patch that melted would have had to be pointed at the perfect angle at that exact moment.
So the natural explanation requires this long list of cosmic coincidences all lining up perfectly in a 40-hour window.
It is. It's astronomically improbable. The artificial explanation is just simpler. It argues that if this was a probe, the timing is perfect. You use the sun's energy for a controlled burn, and you make the exhaust look like sublimating ice.
Good camouflage.
Perfect camouflage. The line between accident and design has just never been this thin.
Okay, so let's follow that thought. If we assume it's artificial, why Jupiter? Why ignore us, the habitable planet, and go for a gas giant?
Because if you're thinking long-term, I mean, thousands or millions of years, Jupiter is the real prize in this solar system. It's all about energy and infrastructure.
Energy from a gas giant.
It's a cosmic power plant. Jupiter has the most powerful magnetosphere in the solar system. It generates billions of watts of electromagnetic energy. If you have the technology to tap into that,
You have virtually infinite power source.
you could run entire fleets of probes forever, no fuel needed. And the Hill radius, that stable bubble we talked about, is the perfect place to build out that infrastructure. You can park things there for millennia with almost no station keeping.
And from Jupiter, you have a vantage point on the entire inner solar system.
You do, but there's a darker element to it, the radiation.
Right, Jupiter's radiation belts are famously lethal.
To life like us, yes. But for machine intelligence, that radiation provides cover. The intense electromagnetic noise is the perfect natural jamming system. It would make it incredibly difficult for a primitive civilization like us to detect faint electronic signals from their network.
So the indifference to Earth, it might be because we're not important. We're just data points for a mission focused on setting up a permanent, hidden, self-powered base.
Which leads right into what's called the Sentinel Theory, the idea that advanced civilizations don't send single ships. They send automated carrier craft that deploy vast networks of smaller, autonomous probes.
And 3i Atlas fits that description perfectly. A delivery vehicle.
And its delivery targets would be the Lagrange points inside that Hill radius.
Zell points, we hear about those a lot. They're stable gravity spots.
Perfect. The gravity of Jupiter and the sun balance out, so an object placed there just stays put with almost no effort. They are the ultimate spots for infrastructure.
So where would these probes be deployed?
2 spots would be key. L1, which is between Jupiter and the sun, would be a great surveillance platform looking at the inner system. But L2 is the real prize for concealment.
Why is that?
It's on the far side of Jupiter, always in its shadow from Earth's perspective. It's almost invisible to our telescopes. It is the perfect hiding spot for the core of an entire fleet.
So we wouldn't see a dramatic arrival. As 3i Atlas crosses into the Hill radius, we might just see what looks like a normal comet breaking up, a fragmentation event.
Exactly. But instead of random debris, the fragments would slow down in coordinated ways. They'd break, turn subtly, and head for L1 and L2.
And these things would be too small and too dark for us to track individually.
Especially operating inside Jupiter's noisy magnetosphere. You could have an entire network built right under our noses, and we just write it off as natural debris.
And this is where people start connecting it back to Oumuamua from 2017.
The thinking is, if Oumuamua was the fast, weird-looking scout that flew by to check things out,
then 3I Atlas is the slower, more camouflaged delivery craft coming in to build the infrastructure.
it's a logical strategy. Send a scout, see what the detection capabilities are, then send in the main hardware designed to blend in. The goal isn't a visit, it's a permanent observation post.
And the timing of all this is what gets me. It's arriving right now at the exact moment our ability to see the sky is exploding.
It's an incredible synchronization. We have the Vera Rubin Observatory, the Euclid telescope.
Yeah.
We're generating petabytes of data every single day. We can't even process it on ourselves anymore.
Which is where the AI comes in.
Right. AI algorithms are now scanning this data, finding patterns a human observer would miss in a lifetime. They're flagging things that appear for a single frame and then vanish, objects with velocities that just don't make sense under normal gravity.
They're finding the anomalies.
They're finding thousands of them, things we used to dismiss as errors or noise. And we're starting to build a catalog of objects that behave strangely.
So the unsettling intersection is that they're arriving, or maybe just becoming visible to us, at the exact same time we're finally learning how to see them.
It forces you to wonder how much we've missed, how many objects we cataloged as comets were something else.
So right now, 3I Atlas is deep in that corridor, heading for its rendezvous.
It is, and the data can support both stories, an amazing accident or a deliberate act. But that margin between natural behavior and artificial behavior is just razor thin.
Which leaves us with the final big question. I mean, it's not just about whether 3I Atlas is artificial. It's about whether we've just been too primitive to notice the watchers who might have been here all along. What happens if our new AI systems finally connect the dots and reveal this grand architecture that we've always just mistaken for nature? What does that do to our idea of being alone in the universe?